Area volume question 3 is from the 2014 exam, question number 2. It is a calculator active question. I'm given a region R, which is defined by f of x and a horizontal line, y equals 4. And I have the graph of it on the right. In part A, I'm asked to find the volume of the solid generated when I rotate around the horizontal line, y equals -2. Because it is a horizontal line, what that tells me is my integration is going to be with respect to x. As I look at my graph and I look at region R compared to where my axis of rotation is, where y equals -2 is, because there's all this space between region R and that axis, I know I'm going to use the washer method. So I set up a blank template for my washer method. So it goes pi outer radius squared minus inner radius squared, and I've got an offset for that axis of rotation being y equals -2. This is an integration with respect to x, so I first need to find my limits, which are just the intersection points of my two graphs. I set up my little equation here, and I find that my intersections are at x equals 0 and x equals 2.3. I don't need to store 2.3 because that is the full value. There's no rounding involved in that number, so I'm just going to call it 2.3. My outer radius is I start at my axis of rotation, which is -2. The one that's further away is my y equals 4 is my outer radius. My inner radius is f of x. As I go to substitute in for my big R, my outer radius squared, I do 4 minus my axis of rotation, which is -2. So that is my R squared. My inner radius is the f of x function. So here's my f of x. When I subtract the -2, I just wrote that as +2. So that is my inner radius squared, and then my dx at the end. Point-wise, if you have the correct limits from 0 to 2.3, you earn a point. If you have the correct integrand, that is worth 2 points. If you did a reversal or you forgot to do the offset for that axis of rotation, you might earn 1 of the 2 points. And then a point for the answer. Just put that thing in your calculator. 98.867 is your truncated answer, 98.868 is your rounded answer, and either one of these would be accepted. It's also important to note that if you just have an answer without the supporting work, it's likely that you're going to earn 0. For that, you wouldn't even earn the answer point. So make sure that you show all the supporting work that shows how you arrived at that answer. In part B, our region R is the base of a solid. Each cross-section perpendicular to the x-axis is an isosceles right triangle. Because I'm perpendicular to the x-axis, that tells me my integration is with respect to x. The area that I'm going to integrate is that of an isosceles right triangle, so I write down that area formula. The reason I don't do 1/2 b times h is because it's isosceles, so the base and the height are the same. And that's what allows this to work because we need to get this down to a single variable. So that alters this area formula to be 1/2 b squared. And as I look at my graph, the base is going upper minus lower, which is 4 minus f of x. So my b, the base, is 4 minus f of x. Once I have my area formula figured out in terms of this question, I just pull it in, and that's what I'm going to integrate. I went ahead and pulled that 1/2 to the outside. You don't have to do that. You can leave that as part of the integrand. Point-wise, you're going to earn 2 points for that correct integrand. The 1/2, like I said, could be in either place. In here, you could write 4 minus f of x, or it's okay to write f of x minus 4. Either one is okay. Then you would just put that in your calculator and arrive at either the truncated answer of 3.573 or the rounded answer of 3.574. In part C, there's a vertical line x equals k, which divides R into 2 regions of equal area. And I'm asked to write an integral expression whose solution gives the value of k, which is that vertical line. So here's my vertical line. I don't actually know where this vertical line is, but I want this pink area to equal the yellow area right here. So I just integrate from 0 to whatever k is of upper minus lower. So that gives me my first integral right here from 0 to k, 4 minus f of x. That's the area of the pink region. And I want that to equal the area of the yellow region, which picks up at k and runs all the way to an x value of 2.3. So from k to 2.3. And again, upper minus lower is the same, 4 minus f of x. So that would be my equation. If you have one or the other of these integrals, you're going to earn a point, and then to set them equal to each other, you can earn that second point. An alternate way of doing this is to look at one of these regions from 0 to k and say that that's half of the entire region. So an alternate way besides that first equation would just be to say from 0 to 2.3, which is entirely region R, and then just cut that in half, and that equals that pink region.